Good afternoon and welcome to another CPD session brought to you by the EdTech Demonstrator Consortium based on ourselves at Hambleton Primary Academy, High Furlong and Ribblesdale. Today we're going to be looking at how you can use microbits in the primary curriculum, even including Python. And this is all about sort of transitioning using microbits just for the normal purpose based on the web-based make code stuff on the website, all the way up to using Python as well. So I'll show you that today. So just a bit about myself. My name is Michael Goldie. I'm the assistant head and also the EdTech lead at Hambleton Primary Academy. We have roughly 230 children enrolled, and we have EdTech immersed within our school quite a lot. We have a one-to-one iPad device scheme in place. We use a lot of wireless board technology. We also use Google Classroom for hybrid learning even now. So we make sure all our homework is on there, and we use all the Google Forms and the full functionality of the Google Workspace for Education Suite. Okay, so let's begin today. I'm going to give you a bit of an introduction to microbits. So today I will be discussing the benefits of using microbits as part of your computing curriculum. So what is the BBC Microbit? Well, this is a pocket-sized computer that introduces you to how software and hardware work together. It has an LED light display. It has buttons, sensors, and many input and output features that, when programmed, let it interact with you and your world. It's simply a piece of hardware, a tiny pocket-sized computer, if you must say. And it's really easy to get started with a microbit. You just need a microbit, a USB cable, and a computer. And to make it work, you just have to tell it what to do by writing a computer program. So for example, you can see there, it's a microbit.hex file. Basically, you use that and you transfer that file onto the microbit, and you can maybe get it to display some text. Let's have a look at it now in a bit more detail. So on one side of the microbit, you will see 25 LEDs arranged as a square. This is used to make simple displays such as smiley faces, hearts, scrolling text, whatever you code it to do. And there are also two input buttons. You have button A and button B, one on the left and one on the right. Now, on the back of your microbit, you will find a reset button just here, and a small plug socket to plug in a battery if you do require it to have a battery as well. If you have purchased a microbit before, you'll probably have noticed it does come with a battery pack as standard. So next we're going to look at microbits in the curriculum. And the first question is, so do microbits actually fit in to the primary national curriculum for computing? Well, pretty much most activities the microbits can be used for will link into the computing programs of study, both in Key Stage 1 and in Key Stage 2. Using the microbit is beneficial and practical way for children to understand coding through physical computing, actually having something sort of in their hand, something tangible. Now, as the microbit can be used for many different activities, this can ensure that children cover many of the objectives set within the national curriculum's computing program of study. This equips them with an understanding of how computers, especially physical devices, surround us in the everyday world, and it just ensures that deep, meaningful links are created during computing learning. And they're also wonderful for cross-curricular links as well. This adaptable piece of hardware can create links throughout topics to ensure that computing can display meaningful connections through other subjects, which help to portray the subject's everyday uses. Now, for example, here, I've put a few here. DT. You can use microbits for all sorts of things. It opens up opportunities to become involved within the computer game focus. So example here, you can have the children design controllers for their microbit to be inserted into, and it provides a focus for the children to create something with a purpose. This does link really well with the aims of the design and technology program of study in the national curriculum. Or for example, in art and design, where children could use Scratch programming and make their own programmable games. This provides opportunities for the children to design and create their own sprites, which are characters, as you can see here, and create their own and offer them the chance to design their own characters and backgrounds that they would like to use when creating their own game. It gives them an idea and gives the pupils a chance to develop these ideas and support them when actually creating them in a computing lesson. This has some great links with the Art and Design National Curriculum as well. Okay, next, using the microbits. Now, BBC and Microsoft, they've sort of partnered up to begin with, and they've ensured that the software to use the microbit is simple and easy to use. It's called Microsoft Make Code Editor. It makes it easy to program your microbit with blocks and JavaScript, and it's powered by Make Code, and that's an online block-based editor which is based on the Microsoft Programming Experience Toolkit, which is abbreviated PXT. This is all web-based software, meaning it can be used on most browsers and does not require you to download any software either. It's ideal for those Chromebook users. Next, we'll look at Python. Now, Python, first of all, I think it's important that I explain exactly what Python is. So Python's a programming language, and it's easy to learn, and it can be used to write all sorts of computer programs. People use Python to build games, online tools, and websites. And Python looks like a mixture of recognizable words, you can see some examples there, and characters, so it can be easily read and understood by humans. It contains collections or pre-programmed code. So for example, display.scroll, okay, that'll display some text and make it scroll along, okay? And what that means is that it can be programmed, then you can use them really easy, and it just makes it easier to write complicated programs. So you've got companies, for example, like NASA, Google, and even animation company Pixar use this language when they are doing any development work themselves. I feel that using Python is great natural progression for children in upper key stage 2. They move on from the Microsoft Make Code Editor, that could be used for year 5. So we currently use Microbits in 5 and 6, with 6 using the Python editor here. And there are some great ideas for using Python in a sequence of lessons as well. And you can see them here. You can start by creating Hello World, go to images, buttons, sensors, using all of these here. And these are some great ideas there. And there are also some great resources and units of work available on TES. TES. Okay, some projects and ideas. So in addition to the software, which can be used in Microbits, there are some great projects that can be used with your Microbits and some great resources to develop your understanding of how to use the Microbit, not just in primary computing, but in all STEM subjects, your sciences, your technologies, okay? For example, on the Make Code website, they have developed a 9-part series, which I've put up here, which is in conjunction with Beacon Hill School. And it's all about getting to grips with the basics of your microbit and give some great ideas about how it can be used to control lights, music, motors. This could be used as part of some great science and DT projects, as well as computing. You could also use it as part of a computing club. This club, using these sort of Make Code, also has some great projects which link with your DT curriculum as well. Furthermore, there's also this website. This is called Club Make. And on here, there are some fantastic resources, once again, for you to really delve into if you're looking to maybe take it to the next level. And finally, there's a great website here. This one's called MB4PS. This has a plethora of brilliant resources with links to loads of fabulous sites and projects. Okay, next. They've brought out a newer Microbit now. So the BBC have released a new version of their original Microbit. This one can now sense and react to sound with its inbuilt microphone and play sound with its inbuilt speaker. They've also given it more computing power, a power saving mode, and a capacitive touch sensor. It's a bit like what's on your phone. Microbit have also developed some great new projects to go with the new features which are available on the Make Code website. And you can see some of them here. You have Clap Arts, Bumblebee, Hold the Note, and Mimic. They could make some great links to your music curriculum. And this latest microbit will fit right into existing lessons and materials. All the existing make code blocks and MicroPython code will work in the same way as they do on the original microbit. The previous microbit will continue to work just as it did before. There are more features which constantly get updated as you go through the software updates. So where can you buy microbits from? Well, there's loads of places you can buy microbits from, including Amazon, but to get better prices when buying in bulk, because you'll be buying more than one or two, I imagine, if you visit the link above there, the microbit.org/buy, that link there, you will find a list of reseller companies who will sell devices all around the world. And a good idea as well is to even ask your local high schools. If you borrow a small set, as most high schools were giving out a set for all their year 7s a few years ago when they first came out, they might be able to loan you a few for free to try out. Also check out Amazon for some great microbit kits. These also include things like hardware extras, sensors, LEDs, inputs, and speakers, really bringing your microbit to life. Okay, a couple of tricks for keeping your microbit up to date. I bring this up because even if you have, such as myself, a big selection of microbits, if you don't keep the software up to date, it will not work and you will get line error codes. So what do you need to do? Well, I'm going to give you some tips and tricks to ensure you can easily code with your microbit. So the first thing is it's all about updating your firmware. That is what you need to do. Keeping your microbit up to date is really important. And if you're having technical problems with your microbit, installing the latest firmware will probably clear them up. Updating the firmware also lets you take advantage of the latest features and big fixes. And you can find the current version of firmware installed on your microbit by connecting the microbit to your computer with the USB cable. Open up the details.txt file, which will be in a sort of browser, or it won't be in a browser, sorry, it'll be in a folder on your computer, and look for the number written beside the interface version. And to ensure you've got the latest firmware update, download the .hex file from this link here. This next, with the battery pack removed, make sure you plug your USB cable back into your computer and make sure your microbit is connected. When you connect it back into your computer, while plugging it in, hold the reset button down in the back of your microbit. Your microbit will now go into something called maintenance mode, okay? As you can see here. You need to take the hex file you downloaded from the internet site I just showed you earlier and drag it into the maintenance drive. And you should now see a flashing yellow LED on your microbit. Once it stops flashing, the update is complete. The microbit should automatically eject itself from the maintenance mode and return to its normal state. Done. And you should now see a drive called Microbit on your computer, just like that. You can open up the details.txt file to ensure that the update was successful. And when pairing the device, the software you are using should make it quite clear on how to do this. And it's usually quite self-explanatory. Okay, so finally today, I'm going to give you a very simple but live demonstration on the basics of using Python and a microbit. This is the version 1.3, so it's the first version. Okay, it doesn't have things like the sound inputs and microphones on them. So the first thing I'm going to do now is I am just going to stop sharing my screen with you, and I'm going to share my Python screen. So you should see that come up just now, I'm hoping. Okay, so this is my Python screen here. This is great because you can see up here, it just loads up. It's a web-based piece of software. You don't need to download anything for it. And the best way to find it is by simply Googling Python and Microbit, and it should bring it straight up. So I've put some code in here for you already. The first thing you need to do is make sure you write here from Microbit import. If you do not put that, it will not be able to read what is on the microbit or send the text, the code to the microbit. The first thing you need to do is get your microbit, plug in the small end of the USB, and then connect it in. Now, if you're on a Windows device like myself, you will find that it makes a bit of a noise. And what will happen is it should boot up and show you that that Microbit folder comes up. You can't see this because I'm just sharing the file, but I definitely know it's connected. But up here, it's not. So the first thing I'm going to do is I'm going to click Connect, tick here, and click Connect. And now, as you see, it's got some smiley ticks and I'm ready to go. So the code I want to do today is I've already preloaded this ready. I want to display on a scrolling message, hello world. Then I want to display but just show a picture of a heart. And then I want my Microbit to go to sleep at a rate of 2000, which is the speed that you want to go to sleep. So by clicking flash, I'm hoping you can, letting it away. By clicking flash, you should see now it's saying, hello world, with a love heart, and then you're done. Okay, so I'm hoping you can see how simple it is to get started and get going with a Microbit, okay? That is just a simple bit of code, and that is really looking at the basics of using Python. I'm just going to now come back to the screen and just finish off today's session. Just bear with me. Okay. Okay. So the final thing is just to let you know that I do have some resources with Python and using Microbits with a sequence of lessons. And if anyone does wish for any of those further resources, you can always contact me via @GoldieTeach. If you're looking for further support from the EdTech Demonstrator program, please Google EdTech Demonstrator and complete one of the expression of interest forms through the United Learning websites. Or alternatively, please visit our EdTech Demonstrator Consortium YouTube channel, click subscribe, and you'll get notifications when all our newest updates and videos come on. Today's video will be available on there shortly. And for me today, I'm finished. I hope you've enjoyed today's session. Anything you need, any questions, please get in touch. Thanks for your time. Bye for now.